Hey Chemistry, Mrs. KJ here, going over lesson 1.12 for Core Chemistry, Semester 2, Some Properties of Liquids. A liquid takes the shape of its container, but may not fill it. Liquids are a state of matter where the molecules are held together more tightly than in gases, but less tightly than in solids. So think about that. You pretty much already knew that because you know gases float around and fill up the room. You know liquids are splashy and sploshy. Yeah, that was real scientific for you. And solids keep their shape. And that all has to do with how close and tight the molecules want to be to each other. Like gases, liquids can flow and take the shape of their containers, but they have a definite volume and might not fill the container. That means if I have 1 gallon of milk, it's 1 gallon of milk whether it's in a pitcher, whether it's in a jug, whether it's on the floor. It's 1 gallon. Their properties are determined by the interplay between their molecules' intermolecular forces and kinetic energies. So kinetic energies, the fact that they're moving, intermolecular forces. That means if I have H2O, I have many molecules of H2O. And inter means between. So it's how the molecules interact between each other. So for example, when I have H2O, the hydrogen end is partially, that's what that little squiggly means, partially positive, and the end with the O is partially negative because there are more electrons on that end. Well, if there is another molecule of water, it's going to line up where the partially negative oxygen is going to be attracted to the hydrogen of another molecule. So you're never going to see this hydrogen next to the molecule I drew in black, next to that hydrogen. No, it will never, ever, ever happen because they are attracted to the next molecule by positive and negative. That's what intermolecular forces is really saying. It's between one molecule and another. In this lesson, you will learn the properties of liquids and how they can be explained by kinetic molecular theory. Liquids properties include strong intermolecular forces. I would prefer to say medium, like gases are weak, liquids are medium, solids are strong. But if they say strong, then you would have to say solids are really strong. Liquids can be viscous, so different levels of thickness or viscosity. They are slightly compressible. They can squeeze a little, but not a lot. And they flow or are fluid. Objectives: describe the atomic or molecular structure of liquids and solids in terms of intermolecular forces, so the forces between the different molecules. Explain why atoms and molecules in a liquid move in random patterns. Contrast the intermolecular forces of atoms and molecules in a liquid with those of a solid. Make sure you hit pause and write down the keywords. Surface tension: the more rigid arrangements of bonds on the surface of a liquid that gives the surface a more integrated arrangement than the rest of the liquid. Okay, think about this. Think about when it's summer, you're at the lake, you're going to go dive in the lake. How do you want to dive in? You either want to dive in feet first or hands first, right? You do not want to belly flop because what happens when you belly flop? It hurts. Why? Because there's surface tension. So the bonds at the surface of the lake, they're stuck together more and they make that harder surface where you can actually slap the water, right? And that is different than once you break that surface tension, then you can swim pretty easily through the rest of the water and it doesn't hurt. But that's surface tension. So the top, it's almost like thinking of having pudding. Like pudding has a film on the top where it gets like homemade pudding. It gets a film on the top where it's a little bit thicker. Same thing with water, we just can't see it. But you can feel it if you belly flop versus pencil dive or dive correctly hands first. Vapor pressure: the pressure exerted by a gas on a liquid in a closed system. So if I have a cup of water, there is pressure on the air above my water in the cup that's pushing down on the water. So air pressure, just like atmospheric pressure is pressing on your eyeballs right now and everywhere else. Viscosity: a measure of a liquid's tendency or resistance to flow. In other words, how thick it is. Maple syrup is very viscous. Honey is viscous. That means thick. It has a high viscosity. Water has a low viscosity. All right, so again, go ahead and go into the lesson if you would like the study guide. And we will go ahead and start right here. A liquid takes the shape of its container but might not fill the container. Okay, you know that. If you have a gallon jug and you only put half a gallon in it, it's going to take the shape of the jug, but it's not going to fill up the whole jug because you only have half a gallon in there. Half a gallon of water, half a gallon of milk in a 1-gallon container. That's all of this is saying. When you think of liquids, probably the first one that comes to mind is water, but other substances can be liquids at room temperature as well. For example, mercury is a liquid metal. Many oils are liquid at room temperature. Under the right conditions of temperature and pressure, gases can also condense into liquids. The water that condenses on the outside of a glass of ice water on a hot summer day comes from water vapor in the atmosphere. So the air around you hits the side of the glass, which is cold, and it condenses. And sometimes they say that your glass is sweating because the outside gets wet. That's why. Liquids are characterized by having a definite volume, but no definite shape. They take the shape of their containers. However, unlike gases, liquids do not expand to fill the entire container. So this is what liquid mercury looks like. Liquids come in many different forms but retain the same basic characteristics. All right. Molecules are closer together in liquids than in gases, but are not as mobile. Oh, sorry. For your notes, definitely make sure you have this sentence here. And you might want to add the other 2 sentences if you're like, oh, yeah, I could, think about yourself. If you're like, oh, there's no way I'm going to get that wrong, fine. But if you're like, oh, no, I get tripped up on little stuff like this, go ahead and write that down. Molecules are closer together in liquids than in gases, but are not as mobile. That's a good sentence to write down. Gas molecules are far apart and move rapidly and randomly throughout their container, colliding with one another and with the walls of the container. By contrast, liquid molecules are much closer together. They contact and slide around with one another. They both vibrate and move from place to place, but they move more slowly than gas molecules. Compared to solid molecules, liquid molecules are somewhat farther apart. While solid molecules are rigid and can only vibrate, but they're still moving, liquid molecules can slide past one another and move along. In other words, they flow. What holds the molecules of a liquid or solid together? The molecules of any substance have kinetic energy. They move. Molecules also have intermolecular forces. The phase of the substance is determined by how the strength of intermolecular forces compares to the kinetic energy of the molecules. All right, I would write that sentence down. And then if you haven't already, write down what intermolecular forces are. It's how one molecule interacts with another molecule next to it. Molecules, phases. All right. So of course, our solids are nice and tight together. I don't know why this isn't moving. The liquid molecules, so these should be shown just vibrating back and forth. The liquid molecules are kind of swimming around. The gas vapors are having a mega party and filling up the whole container. The phase depends on the interplay, or how it reacts, between the molecular forces and kinetic energy. Consider what happens to the molecules of a substance as it is heated from a solid state. Solid molecules are close together. Okay, so in your head, I want you to picture an ice cube. The intermolecular forces are strong. So in our ice cube, the water molecules are lined up really nice and perfect, just like a snowflake, right? A snowflake, the reason we get those nice, pretty shapes is because of the between intermolecular forces. The fact that the water molecules line up because of their partially positive and partially negative ends. And so right here we would have another oxygen, right? And it would keep going. So in a solid we have this nice beautiful structure. Solid molecules are close together and the intermolecular forces are strong. It is strong with that one. Sorry, I could not resist. The kinetic energy may be low depending on the temperature. Therefore, if intermolecular forces are greater than kinetic energy and the molecules only vibrate. Okay, so it's a lot greater. So in other words, there's not enough vibration motion and not enough kinetic energy to cause these to break apart. So if you're like, okay, great, now how do I write that in my notes? You would say Solids stay together because of very strong intermolecular forces and small kinetic energy. So only slightly moving. Okay? As the solid is heated, the molecules absorb energy and move faster. So the intermolecular forces are still bigger than the kinetic energy, but it's not as much. Notice how this has 2 greater than signs, this has 1. Molecules break free from one another, but intermolecular forces still hold them close by. As a result, they slide past one another, kind of like, okay, yeah, I want to be near you, but I'm going to go over to this side of the room. Okay, so how are you going to write that in your notes? Well, let's talk about liquids here. So intermolecular forces in liquids are stronger than the kinetic energy, but only a little stronger. So the molecules flow. Okay, so they just kind of flow by. They're like, oh, yeah, yep, I'm over here. I'm good. See if I can, it won't let me do that, sorry. Sorry, it's under my picture. All right, so intermolecular forces in liquids are stronger than the kinetic energy, but only a little stronger. So the molecules flow. So in other words, this molecule right here, it's like, yeah, I still kind of want to be by you, but now I'm going to go over there. Okay? So still close together, but not as. Now, as the liquid is heated more, the molecules absorb more energy and move faster. Molecules break free because intermolecular forces cannot hold them close. The kinetic energy is greater. So in other words, now there is so much motion of movement. They are moving so much, they're going crazy. They can go all over, right? They're going to fill up the whole container. They don't have to stay in this nice pattern because they're not a solid. They don't have to just kind of flow, kind of keep in the pattern like a liquid. No, they can go everywhere because they have much more kinetic energy than the intermolecular forces. So gases, Ke is much stronger than intermolecular forces. It is a party. Okay? All right, and I have no idea where the rest of my words went. So kinetic energy is much stronger than the intermolecular forces. They party and go crazy everywhere. All right, so we have a molecule thermometer. Let's see if this one works better. There we go. Okay, so remember the thermometer. The more the thermometer gets hit, the more energy is transferred and the more the molecules inside move and the higher it rises. Here it's bumping it a little, so it's at 0. Here it's getting bumped more often, so it has more energy, so the inside can go up to about here, which is 50 degrees. Over here, man, it's getting hit like crazy. It's so hot, it's all the way up to the top, 200 degrees Celsius, because it's being hit the most. What determines whether a substance will be liquid at certain conditions? Now, I know most of you are thinking, well, isn't it just how hot it is? Partially, but there's a little bit more to it. 3 factors determine whether a substance will be a liquid at any given temperature and pressure. Okay, you've all heard in the movies where they're like, oh, and now we have liquid oxygen, and now we have liquid hydrogen, and all this stuff, right? Well, they don't actually get it cold enough. They pressurize it. They squeeze those molecules so close together, they force them to act like liquids, and they become liquids. They force them to be solids. Yeah, I could have a solid chunk of oxygen. How weird is that? Okay, but you have to know these 3 things. So strength of intermolecular forces. Strong intermolecular forces will draw the molecules close together and hold them there. So some molecules just want to be close together or lined up in a certain way, like water wants to be lined up like this because of the partially positive and partially negative ends. Molecular mass. Kinetic energy depends on mass and velocity. For the same kinetic energy, higher mass molecules, so really big ones, really fat ones, travel more slowly than lower mass ones. Now, I use the term fat so you can think about it. If I had an Olympic sumo wrestler and he was racing a gymnast for the 100-meter dash, who would win? The gymnast,